Okay, in this video, we will do this problem. Okay, let's read this. The problem reads, find z1 such that the probability where z is between 0 and z1 is equal to 0.3508. Okay, and if you recall, this is a problem that I titled From P to Z, where you are given the p. This 0.3508 is p value, the percent or probability, and you're asked to find the z value. Okay, let's draw a picture. Okay, so the middle is 0 for the z, and somewhere on the positive side, gotta be positive because the z1 is greater than 0. That area here is this. And remember, this is what I call A of z1. And A of z1 is 0.3508. So this is the one where we use this table, but go backwards. Okay, so amongst this many number of p-values, percent values, look for 0.3508. Okay, and where is 0.3508? And I see that right here, 0.3508. Okay, and that number corresponds to the z value of 1.04. Okay, so our answer then is z1 is 1.04. That's it. Again, this is one where we are going backwards. Okay, I got two more problems in the same video. B is going to be p probability z less than z1 is equal to 0.0655. Okay, here this problem is a little bit harder to visualize than A, because here this A was quite obvious that z1 is a positive. Why? Because it's greater than 0. Here is z1 positive or negative. Okay, all we know is that the z1 is larger than all the z's that we are dealing with. Okay, so let's see. What we know is wherever this z1 is, whether it's a negative or positive, we are going in this direction, all because of this inequality symbol. Okay, we are not going to the right side, we're going to the left. All right, and let's say our z1, let's kind of guess. Let's say our z1 is here on the positive side. Okay, and what this problem is saying is the area under the curve is the 0.0655. Okay, and I hope you realize that that cannot happen if z1 is positive. Okay, so that z1 must be negative. Reason being, the area that we are given is this. They're saying which z1 corresponds to this little tail. Again, I kind of exaggerated so that you can see that a little bit more readily. Okay, so I hope you can see that this green shaded area is this given p number. Okay, all right, now of course using our table, this is what I call A of, actually I'm going to be mathematically correct, negative z1. Okay, all right, don't worry too much about that negative sign for now. Okay, and the green shaded region that's given to us, okay, is 0.0655. So that means this A of negative z1 must be 0.5 minus 0.0655. Okay, again because that is 0.5. All right, so do this subtraction, and that gives me 0.4345. And that's the number you should be able to find in your table where is 0.4345? 0.4345 is right here, 0.4345. Okay, and that corresponds to the z value of 1.51. Okay, 1.51. All right, so we found our z value. Remember, I started out by saying that negative z1 is 1.51. Okay, that means z1 that we are after must be negative 1.51. Okay, so that is our answer for part B. Okay, and I have one more here. C. And that is find P. Z is now greater than Z1. That is equal to 0.6977. Okay, let's draw a picture. Here's our 0, Z, and our Z1 is going to be somewhere either negative or positive. Okay, we don't know that yet. What we know is that the area that we are interested in is going to be going in that direction because of the inequality symbol. Okay, Z greater than Z1 means we're going to the right. Okay, again, Z1 could be either on the positive side or on the negative side. Alright, and I hope you can see that since this number is larger than half, larger than 0.5, it just cannot be this positive Z. Because from there, all the way to the right, cannot be greater than 0.5 like this number is. That means our Z1 must be this. Okay, and the number given to us is actually that right there. All right. Okay, and going back, the area given to us. Let me draw one more picture. I could do some more on top of this, but it's going to be a little confusing. Of course, what's given to us in the table is only this portion right here. Okay, comparing these two, hope you can see that this is A of Z1, which is 0.6977. Remember, that's the whole everything. Okay, the green. Subtract 0.5. Okay, why 0.5? Because from 0 all the way to the right is 0.5. And that should give me 0.1977. Okay, and that's the number that we're going to look for in our table. All right, 0.1977. Where is that? That is 1977. 0.1977. Okay, well, I don't see it here. Okay, what does that mean? What that means is I'm going to be looking for the number that is closest to this. Okay, there is no 0.1977. Okay, the two closest are 0.1950 and 0.1985. Okay, so we're going to look at the Z's and A of Z. Alright, then this Z, the first one was 0.1950 and 0.1985. What we want is 1977. Okay, 0.1950 corresponds to the Z value of 0.51. Okay, that's a 0.51. This is the Z1 we're after, and 0.52 should go with a 0.1985. Okay, you do need to look at these three numbers carefully and decide which of the two Z value gives the A that is closer to 0.1977, and it is this 0.51. You can see that 0.1985 is closer to 0.1977 than 0.1950 is. Okay, so there are two ways you can write the answer. Our Z1 is actually going to be negative, about negative 0.52, or another way you can say is negative 0.515. Okay, in another video I'm going to show you a little bit more accurate way of estimating the Z1, and I briefly mentioned before, and that is called a linear interpolation. All right.